question 2 on photoelectric effects, and this was taken from the Department of Education's November exam 2008. This is in your physics paper, by the way, so this is always paper 1. A fully automatic camera has a built-in light meter. When light enters the light meter, it strikes a metal object that releases electrons and creates a current. This has been underlined. That means it's important. There's something they want to do with that, okay? And the first thing they ask you is, what phenomenon is described by the underlined sentence? This is just another way of asking a definition. This is the definition of the photoelectric effect. Nice and simple. Okay? A metal is irradiated. All that means is we shine light on it with an electromagnetic radiation of 200 nanometers. So wavelength is 200 nanometers. So that's 200 times 10 to the minus 9 meters. The metal has a work function, so that's WO of 7,57 times 10 to the minus 19. It's tiny and it's expected. Show by calculation that the metal plate will emit photoelectrons when irradiated with the radiation of this wavelength. There is more than one way you can work this out. Okay? So the one way is to calculate the frequency of the light that's needed, or, and this is a little different to, if you've got the memo, to what you'll see on the memo. The other way we could have done this is if the energy of the photon we have is bigger than their work function, then we'll get electrons emitted. So if we go E equals hc over lambda, okay, remember C equals F lambda, so F equals C over lambda. Oh, that's not C over lambda. That's C over lambda, and E equals HF, okay? So that means I'll go, and H is a constant, 6,63 times 10 to the minus 34. C, I'm just going to take this out so I can write it in, is 3 times 10 to the 8, and lambda was 200 times 10 to the minus 9. Now, if you don't do the conversion, this isn't going to work for you because your answer will be wrong, basically. And when we do this, I get 9,95 times 10 to the minus 19 joules. Okay? The question is, show by calculation that light will be given off. Well, E is greater than the work function. Therefore, photoelectrons will be emitted. Alright, it's just a simpler way around. It's another way around. It's perfectly acceptable. You're comparing it to the work function. You could have worked out the frequency of the wave when its wavelength is 200 nanometers, then worked out the threshold frequency and compared the two. And if the frequency of the 200 nanometers is bigger than the threshold frequency, then we'd emit electrons. Okay. The intensity of the incident radiation on the metal plate is increased, in other words, it's made brighter, whilst maintaining a constant wavelength. State and explain what effect this change has on the following. First of all, the energy of the emitted electrons. No effect. Okay? It has no effect whatsoever. Why? Because the frequency didn't change. Energy is affected by frequency. Okay? Then they want the number of emitted photoelectrons. Well, that's going to increase. Why? Because an increase in intensity, okay, an increase in intensity increases the number of photons hitting the metal. Okay, so it increases the number of photons hitting the metal, and because it increases the number of photons, that means we'll have a bigger current, we'll have more electrons being emitted. There's more collisions. Okay, that's question 2.